The next series I want to talk about is something called the alternating harmonic series. So remember the harmonic series, right? That's our sum 1 plus 1/2 plus 1/3 plus 1/4 and so on. And we knew that that diverged. Now, what if I add an alternating pattern of sums and differences in there? In other words, I do 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 and so on. What if I do that? Does that converge? Does that still diverge? Let's find out. Right? What we're going to do here is look at the sequence of partial sums. Right? So here again, I've wrote out my partial sums, right? The formula for the nth partial sum. And then I want to plot these. And here I'm plotting the first 20 partial sums. So if we look at this, it starts up here at 1, and then it goes down to 1/2, and then up, and then down, and up, and down, and up, and down, and up, and down. Right? And it's sort of ping-ponging back and forth. But the amount it's bouncing back and forth by each time gets smaller and smaller. So if we look at this, it should look to you like it's converging, in fact, to some number. The number's not super important here, but it is actually converging. Right? So this this series here is sort of a generic example of how what we will call an alternating series converges or diverges. Right? So an alternating series is a series of this form. Right? It could have, k plus 1 here, or it could just have a k. It doesn't really matter. Both of them are considered alternating series. So I'll leave the plus 1 here, just so it starts off on a positive note. Right? So this kind of a series, it's actually somewhat easy to check if these converge. Remember before that a series, if the limit of the terms went to 0, that doesn't mean anything about its convergence or divergence? That's a little bit different than, or a little bit different for the alternating series, right? So here, this alternating series will converge provided two facts, okay? The first thing we need to know is that the sequences are the sequence of terms that we're adding up if we ignore the alternating bit right here, right? We need to know that those decrease in magnitude. All right? So first off, they're all positive numbers, right? So it should be, an alternating sum and difference of positive numbers. Right? And then we want to know that each number is smaller than the previous one. Now, again, I want to emphasize, going back to this last fact here, we don't need to worry about the first few terms. We just need to know that at some point, these things start decreasing in magnitude. All right, and then the other thing we need to know is that the limit of that series, or of that sequence, goes to 0. Right? So as long as the AKs are approaching 0, and at some point they start getting smaller and smaller, if we take this alternating series, it has to converge, which is pretty neat, right? So let's do some examples of these, right? So let's use the alternating series test to see whether these converge or not. Okay, let's start with something somewhat simple here. So 1 to infinity. We have minus 1 to the k plus 1 over k squared. We want to know, does this converge, right? Or, do we just not know? Right, so if we look at this here, this is, let's write it this way. I want to emphasize here that the 1 over k squared, this is our AK in this case. All right. So one thing we're going to check here is, AK, which is 1 over k squared. This is always positive, right? That's always true, which is good to know. And let's look at AK plus 1. Right? This is 1 over k plus 1 squared. And the question is this less than 1 over k squared, which is AK? Is that true? Right? We need to know, is this inequality right here a true statement or not? Well, we can sort of cross multiply this. And that tells us, well, k squared is less than k plus 1 squared. And that's true. Right? K squared is less than k plus 1 squared. So 0.1 is good. So I'll call it item 1 is good of the alternating series test. Item 2, so that's, maybe let's call this I guess. Call this II. Because now we want to check the second thing in the alternating series test, which, remember, the two things here were, again, the first thing we were checking is, are all these terms positive and are they decreasing? And here it's always decreasing, so we're good. And then the other thing we want to check is the limit 0? Right, so let's check, is the limit 0? Right, so limit, this k goes to infinity, of 1 over k squared. Well, let's go ahead and just write this out. This is going to be 0 because we have a constant on top and a term that's going to infinity on the bottom. So yeah, that's going to be 0. And that's item 2 in the alternating series test passed. So here what we would say is the series sum from k equals 1 to infinity of minus 1 to the k plus 1 over k squared converges by the alternating series test. Right? So again, we don't know what it converges to, but that's not so important in a lot of cases. Often in math, we don't really need to know what the actual value is. We just need to know, is it finite or not? Right? And that's the most important thing here, and that's what we have an answer to. Right, and let's look at one more example. Call this example 2. And here, I have this one written out as a sum, like this. All right. So if we look at it like this, we need to write out, okay, well, what is the values here? What is the AK? What does the terms look like? Well, so here, what it looks like is here we have, a number over the number before it, a number over the number before it, a number over the number before it. So here, this can really be thought of as 2 over 1. So what we're really doing here is if we say, well, this is k plus 1 over k, then k starts at 1 and goes to infinity. Right? And then it's alternating. So we usually would write this first, but it doesn't really matter. Since we start on a positive term and k starts at 1, we need k plus 1 here. Right? That way all the odd terms are positive. So now that we got that, we can say, all right, well, AK is k plus 1 over k. And these are indeed positive numbers, so we're safe there. Now the question is, are these decreasing in size? Well, in fact, they will be. However, I want to say we can apply either test first. So let's actually look at item 2, all right? The limit of the AKs. Right, this here is 1. So item 2, as I've apparently started calling it, it does not pass that. So, well, the test then is, so I guess we would say here is the alternating series test is inconclusive. However, can we still say anything at all about this? Well, the limit of this overall, what's going on there, that limit doesn't exist, right? If we look at the overall limit, so this thing here, this does not exist. In particular, it's not equal to 0. So this diverges by the divergence test. Right? So, we can always sort of fall back on other tests here, and that's the importance of having a few different options, is there's always something to fall back on. Right? So, yeah. So I think we'll stop there. And we've done quite a few different examples here. And then we'll do one more test for tomorrow.